Viewers, in this video we'll see the 8421 BCD to XS3 code converter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. It's a code converter, that is BCD to XS3 code converter. We'll see the what is the truth table, what is the logic diagram, how to convert the BCD to XS3. What is the logic circuit for that? We are going to develop the logic circuit for this converter. So the XS3, first we will see what is meant by XS3 code. XS3 code is a modified form of a BCD number. The XS3 code can be derived from the natural BCD code by adding 3 to each coded number. So XS3 means very simple. With the BCD we need to add the 3. By adding 3 with BCD, we will get the XS3 code, right? So this code is used for transmitting the data representation for other purpose. That's why we are adding 3 with BCD to get the XS3 code. For example, the decimal number 12 can be represented in a BCD as 0010010. That is by using 8421 weightage. 8421. Right, the last digit is 1 means it is 1. 8421, right, the second digit is 1 means it is 2, right. So 1 is represented separately by 4 digits, 2 is represented by the 4 digits separately by using the weightage 8421. So XS3 means with this 1 we have to add 3, 1 plus 3 become 4, 2 plus 3 become 5, right. So 45. So XS3 code for a decimal number 12 in a BCD is nothing but 45. Now 4 is represented separately 0, 1, 0, 0. Then 5 is represented as 0, 1, 0, 1. Right. So here we are using the weightage 8421. Here also 8421. See this, the second digit is 1 mean it is 4. Here second and fourth digit. So that 2, 4 plus 1, 5. Right. So it is represented by the weightage 8421. So XS3 code means with the decimal number by adding 3, what we got is the XS3 code. For example, 12 means 1 is added with 3, so it become 4, 2 is added with 3, it become 5. Again after that the 4 is represented separately by 4 digits, this 5 is represented by the 4 separately by the 4 digits using the weightage 8421. Right. So now it is very clear, BCD to XS3 means with that BCD we need to add the decimal number 3, then with that added value we need to again represented by the BCD code using the weightage 8421. Right. Now we will see this input code. What is the input code? Is nothing but BCD code. We will take D3, D2, D1, D0. D0 is the LSB, D3 is the MSB. Least significant bit, most significant bit. Then the output code is XS3 code. So we will represent it as E3, E2, E1 and E0. So E0 is the LSB, E3 is the MSB, right. So now we have assigned the input code and output code. Input code is represented by the D, output code is represented by E. Now we will see the truth table so that we can develop the logical expression. From that we can develop the logic circuit. Now we will go to the truth table. So this is the decimal equivalent 0 to 9. So that is represented by the BCD code. So this is the input, this is the output. Right. So this BCD code again it is represented by 8421 representation. Since the XS3 also represented by 8421 weightage. Right. Now we will see that. First we will see the input, the decimal 0 to 9. Right. The 0 is represented 0, 0, 0. 1 is represented, the last digit is 1. Right. 2 is represented by second digit is 1. 3 is represented by second and third. 2 plus 1, 3. So that 0, 0, 1, 1. 4 is represented by this third digit. I am telling from the MSB. Third digit is 1. So that 0, 1, 0, 0 means 4. 5 is represented by this 4 and 1, that is first digit and third digit. First digit and third digit 0, 1, 0, 1. So we will get 5. So like that it is represented. By using the weightage 8421, we are representing the BCD. It's a normal one. Normal BCD number is represented. Then what is excess 3 in decimal? First we'll see the decimal, then we'll go to the code, BCD code. So 0 plus 3 is 3. With the 0, we are adding 3. 1 is added with 3 from 4. 2 plus 3, 5. 3 plus 3, 6. 4 plus 3, 7. Like that we are adding. Now the excess 3 code is become 3, 4, 5, 6 up to 12. Right here from 0 to 9 is there. While adding 3, it become 3, 4, 5 up to 12 is available. Now this bracket, what is the number, what is available in the bracket is the excess 3 in the decimal. That number should be represented in the binary code, BCD code, right? So the 3 means 0, 0, 1, 1. That is, this 1 is 2, this one is 1. So 2 plus 3, 2 plus 1, 3. Then 4. Here 4 is available. So that this digit is 1. So that 0, 1, 0, 0 means 4. Right. 5. How will you get the 5? Second and third. So I am telling from MSB. Second and third, second and last. If you put second and last is 1, second and last is 1, what is the value? 4 plus 1, 5, right? Then how will you get 6? Second and third, 4 plus 2, 6, right? So 0, 1, 1, 0. If you put 0, 1, 1, 0, what is the meaning? This 4 plus 2, 6. So like that we can represent the other values up to 12. How will you represent 12? 12 means 8 plus 4, 12 is there. So 1, 1, 0, 0. 1, 1, 0, 0. 1 means this is 8. This will be 4, remaining 0. So 8 plus 4, 12, right? Now this is the equivalent excess 3 code, right? So these two column is the input code BCD. It is a decimal, then equivalent BCD. These two column refer the output code, excess 3 code. Excess 3 code in decimal, that is 0 is added with 3, 1 is added with 3, so that we got the excess 3 code in decimal. It is available in a bracket. The number available in bracket is the excess 3, that is again represented by the excess 3 code by using the weightage 8421. Now we need to develop the logical expression for this E0, E1, E2, E3. Then that logical expression should be implemented with the logic gates, so that we'll get the input decimal to output excess 3 code. Now we'll go to the Karnaugh map. By using the Karnaugh map, we can obtain the simplified form of the Boolean function for E3, E1, E2 and E0, E1, E2 and E3. Right? Wherever 1 is available, it is marked as 1. Wherever 0 available, it is marked as 0. For example, in E0, 1, 2, 3, 4, 5. 5 ones are available. In E1, 1, 2, 3, 4. Here also 5 ones are available. In E2, 1, 2, 3, 4. 5 ones are available. E3, 1, 2, 3, 4, 5. So everywhere 5 ones are available. These 5 ones are represented in the K map and will get the simplified form of Boolean function. That function can be implemented with the logic gates. So now we'll go to the Karnaugh map in order to get the simplified form of Boolean function for E0, E1, E2 and E3. First we will see the Boolean function for using the K map for E3. First we'll go for E3, right? So this is the 4 variable K map, because input what we have 4 variables are available, D3, D2, D1 and D0. This is nothing but the BCD code. E3, E2 is the excess 3 code. So we are converting from BCD to excess 3. For that only we are going to obtain the Boolean expression, right? So the input code is D3, D2, D1, D0. D3, D2 represented in a vertical manner, D1, D0 represented in a horizontal manner. It is a 4 variable K map. So D3, D2 means 2 variables, so 4 combinations are available, 0, 0, 0, 1, 1, 1, 1, 0. The third and fourth row is interchanged. Similarly, D1, D0, 2 variable having 4 combinations, 0, 0, 0, 1, 1, 1, 1, 0. Here also third and fourth column is interchanged. That is the nature of the K map, right? So in this K map, we need to represent the numbers available is marked as 1. That is for E3 we already discussed, there are 5 ones are available. So this 1, 2, 3, 4, 5 ones are available. So from 0 to 9, we convert 0 to 9, we are having the code. From 10 to 15, the code is not available. So that is not needed. So that is taken as a don't care condition. right? That these six are don't care condition. From starting from 10 to 15, the 6 numbers are available, right? These are all the don't care condition. So in the K map, we can represent the min term directly. That is, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is nothing but 10. This is 11. 12, 13, 14, 15, right? So 10, 11, 12, 13, 14, 15. These are marked as a cross mark. That is nothing but don't care condition, right? By using min term, I am explaining using the min term. This is nothing but 10, 11, 12, 13, 14, 15. So these 6 numbers are marked as don't care condition, right? So there are 5 ones available, that is we analyzed from the truth table. Remaining 6 are, that is from 6 to 10 to 15 as a don't care condition, right? Now by grouping this grouping this cell, we can obtain the minimized expression, right? First we will see any 8 grouping of 8 possible cells are available. So first we will see 8, then 4, then 2. So here 8 possible cells are available, grouping of 8 cells. So this don't care condition, while grouping we can use it, but it is not necessary to group all don't care condition, right? If it needed, we can use the don't care condition, otherwise we can leave it. So there two ones are available. Here the don't care conditions are available. So we are using all these don't care conditions to group the 8 cells, right? We are grouping all 8 cells. So while grouping this 8 cell, we have to refer the corresponding third row and fourth row. Similarly, first column, second column, third column and fourth column, because this grouping covers all 4 columns and this third and fourth column. So while covering all 4 columns, 0, 0 cancelled by 1, 1. 0, 1 cancelled by 1, 0. Because here 0, here 1, here 1, 0. Here 0, 0, 1, 1. All are cancelled. Only this we have to refer third and fourth row. What is available in third and fourth row? 1, 1 and 1, 0. See, this 1 is available commonly from third and fourth row. Here 0, 1 is available, here 0 is available. Second number that got cancelled. So only the first number is 1 available in both third row and fourth row. What is this one? 1 is nothing but D3, right? So this is the D3. While grouping 8 cell, what we got? D3, right? Now we'll go to another 2 groupings are available. These two 4 cells are grouped and these 4 cells are grouped together. So while grouping, first we will see this grouping of 4 cell, green color, right? So we have to refer the second row and third row, second column and third column, right? What is available in second row and third row? 0, 0, 1, 1. See, this first one is 0, second here, the first number here 0, here 1, got cancelled. Second number is 1, available in both the second row and third row. So the second number 1 is commonly available. First number got cancelled. What is second number? It is D2. So we will write it as D2, right? Now we have to refer the corresponding the second row and third row, second column and third column. Here 0, 1 available, here 1, 1 available. So the first number 0, here 1 got cancelled. Second number 1 available in both second column and third column. What is the second number? D0. So this is D0. D2 into D0. So by grouping these 4 cells, green color, what we got? D2, D0. Now we'll go to the grouping of these 4 cells represented by the blue color. So again similarly we have to refer the second row and third row. So what we got? D2. Well, it's the same thing. The grouping of this cell is very similar to this cell for referring third row and second row and third row. There we got D2. Here also D2, same thing, we got D2. Only this third column and fourth column is differ. What is available in third column? 1, 1. Fourth column 1, 0. So the first number available commonly. What is first number? D1. So it is D1. Second number here 1, here 0. Got cancelled. So 1 is got cancelled by 0. So it is D1, right? So for this green color, what we got? D2, D0. For blue color, we got D2, D1, right? So this is nothing but D3 plus D2, D0 plus D2, D1. The D2 available commonly, so taken commonly. So we get D0 plus D1. So finally we have D3 plus D2 of D0 and D1. So that is for expression for E3. Now we'll go to the E2, right? Again, so these 6 cells are don't care condition. 10, 11, 12, 13, 14, 15. So other 5 ones are available. We discussed in the truth table. So 1, 2, 3, 4, 5. These 5 ones are marked together. Now we'll go for the grouping, right? So first we'll see group these two cells. There is no other possibilities. The second grouping is these two cells and these two cells are grouped together. So grouping of 4 cell. Similarly, these two cells and these two cells are grouped together. That is grouping of 4 cells, right? So first we will see the grouping of these two cells. What is this? How to refer this? We have to refer the second column and second row and third row. What is second row and third row? 0, 1, here 1, 1. So the first 0 is available, here 1 is available, first number, so got cancelled. Second number is 1, 1. What is second number? D2. So we'll write it as D2. Same thing what we discussed here also. Second row and third row means D2, right? So correspondingly, what is available in first column? 0, 0. 0, 0 means D1, D0. That is D1 bar, D0 bar. D1 bar and D0 bar, right? So while grouping these two cells, what we got? D2, D1 bar, D0 bar. So while grouping 8 cells, we'll get only one variable. While grouping 4 cells, we'll get 2 variables. While grouping 2 cells, we'll get 3 variables. It keep on increases, right? Now we'll go to the next one. First we will refer this red color, these two cells and these two cells. So we have to refer the first row and last row. Similarly, second column and third column. What is available in first row? 0, 0. Here 1, 0. So the first number here is 0, here 1, got cancelled. Second number is 0, here also 0. That is commonly available. What is second number? D2. That means D2 dash, right? Then what is available in second row, second column and third column? 0, 1, 1, 1. So the first number here 0, here 1, got cancelled. Second number is 1, available in both the column. What is second number? D0. So D2 dash, D0, right? So by grouping this red color 4 cells, what we got? D2 dash and D0. Then we'll go to this blue color. These two cells and these two. Again we have to refer the first row and last row. While referring first row or last row, what we got? D2 dash. We already discussed with the red color. So here also D2 dash. Only this third column and fourth column we have to refer. In red color we refer second and third column. Here third column and fourth column. What is available? 1, 1, 1, 0. So the first number 1 is available in both the column. The second number here 1, here 0, got cancelled. So the first number is nothing but D1. So what we got? D1. So the final expression is D2, D1 dash, D0 dash plus D2 bar, D0 plus D2 bar into D1. The D2 available commonly is taken outside. So D0 plus D1. Now we got the expression for E2. Now we'll go to the expression for E1 and E0. E3 and E2 is completed. We'll go to E1 and E0. So for E1, again we discussed these 3 are don't care condition. The other 5 ones are available. So 1, 2, 3, 4, 5. These 5 ones are marked together, right? So here what we are doing, these 4 cells are grouped together and these 4 cells are grouped together. So this don't care condition while grouping we can use, but the no need to group the don't care condition. It is not necessary to group all don't care conditions, right? Here we are required, so we are using this don't care condition. Here also we are required, so that these two don't care condition we are using. But these 3 are not covered, so it is not necessary to cover all don't care condition, right? So while grouping these 4 cells, we have to refer first column, first row, second row, third row and fourth row. Then first column. So while referring row, first row, second row, third row, all are cancelled. 0, 0 cancelled by 1, 1, 0, 1 cancelled by 1, 0. So we have to refer only the first column. First column 0, 0. What is that? D1, D0. That is D1 dash, D0 dash. Because of 0, 0, D1 dash and D0 dash. Similarly, here this grouping of these 4 cells. Again we have to refer the all rows. They got cancelled. Only we have to refer the third column. Third column is 1, 1. 1, 1 means D1, D0. Right. So here we have D1 dash, D0 dash. Here D1, D0. What is this? This expression is nothing but the exclusive NOR gate. D1 exclusive NOR of D0. By using the single exclusive NOR gate, we can implement the function E1, right? Because it is clearly available as a exclusive NOR gate function. Now we'll go to the E0. So these 6 are don't care condition. Other 5 ones are available. 1, 2, 3, 4, 5 ones are marked together. Here these 4 cells and these 4 cells are grouped together as a 8 cell, grouping of 8 cell, that is right and leftmost corners, right? There is a grouping of 8 cells. While grouping of 8 cell, we have to refer this corresponding row. So corresponding row got cancelled. Then we have to refer the corresponding column, first column and last column. What is available here? 0, 0, 1, 0. So the first number here is 0, here 1. So got cancelled. Second number is here also 0, here also 0. So only we have to refer the second number. What is second number? D0. 0 means D0 dash. So E0 equal to D0 dash. Right. So now we got the expression for E3, E2, E1 as well as E0. Now we'll go to the logic diagram to implement this E3, E2, E1 and E0. So this is the logic diagram available. This is the input code, BCD code. Here we are going to get the XS3 code. So that we are converting from BCD code to XS3 code. So BCD code is represented by D, D3, D2, D1, D0. This line having the input D3. Similarly D2, D1, D0. In order to get the D3 dash, one AND gate, NOT gate is connected. From D3 the tapping is taken and one NOT gate is connected. So that we got D3 dash. Similarly we have another, in every line NOT gate is connected. So that we got D2 dash, D1 dash and D0 dash. So totally there are 8 possible inputs are available. D3, D2, D1, D0. These lines are represented. While connecting NOT gate we got D3 dash, D2 dash, D1 dash and D0 dash. So all possible 8 inputs are available here. So whichever is needed we can connect to the logic gates, right? So this is the XS3 code. First we start from E0, LSB. So E0 is nothing but D0 dash. We already discussed in the K map. So we are connecting with the D0 dash, right? So here we got the XS3 code, LSB value E0. Right. What is E1? E1 is nothing but XNOR gate of D1 and D0. That also we discuss in the K map, right? So the D1 is connected here. D1 is connected and D0 is connected to XNOR gate. So that we got the output of the digit D1, right? Now we'll go to the E2 and E3, right? E2 and E3 having the more variables. First we'll see the E2. So here one OR gate is available. OR gate means it will add. That is connected with another 2 AND gates, right? So this AND gate is connected from this one input and another AND gate. So this AND gate having D1 dash and D0 dash. This one is nothing but D2 dash, right? So these two are now multiplied together. D2 dash, D1 dash, D0 dash. So this is the one of the required input, right? D2 dash. So this is connected with the OR gate. Another input to this OR gate is this one, D2 dash of D1 and D0. So that is obtained from this OR gate and AND gate, right? So while connecting all these three, we got E2. That is nothing but D2 dash, D1 dash, D0 plus D2 of D1 plus D0. So this is the expression what we got in the K map. So here is a small correction. This is not a D2 dash, it is D2, right? So here it is connected to D2 only. D2, not a D2 dash. In K map also what we have, it is D2, right? So D2, D1 dash, D0 dash is available in this AND gate by using 2 more AND gates. This D2 dash of D1 and D0 is available in this AND gate. By using one OR gate and AND gate we got this. These two are added together by the one more OR gate. So now we got the value of E2. Now we'll go to the E3. What is the value of E3? Is nothing but the sum of these two. D3 plus D2 of D1 plus D0, right? So this OR gate will add these two functions. D3 is connected directly. How will you got D2 of D1 plus D0? This D2 is connected here. This D1 and D0 is available in in this OR gate. So that is connected. This D1 plus D0 is commonly available for D2 as well as D3. So we are using this output commonly to the E3 as well as E2, E2 as well as E3, right? So by adding these two, we got the value of E3. So in this video, we discuss about how to convert the BCD to XS3 code. First, we discuss the truth table. From the truth table, by using the Karnaugh map, we got the simplified Boolean expression. Then that Boolean expression is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.